Right, welcome again. In our today's lesson, we are going to talk about binomial distribution. Binomial distribution. Right, a binomial distribution is an experiment. It is an experiment with two possible outcomes, i.e., probability of success, which is termed P, and probability of failure, which is named Q. So under binomial distribution, we have two outcomes: probability of success and probability of failure. Right. Also, it is an experiment with a fixed number of trials. It is an experiment with fixed number of trials which is called N, right? So the distribution is written as follows: X follows binomial distribution with N and P. So this is the probability of success and this is the number of trials. Then when we want Q, we use Q equals to 1 minus P, since probability of success and probability of failure add up to 1, right? So general formula for probability for P of X equals to X, it is given by N choose X times P to the power X multiplied by Q to the power N minus X. So this is the formula that we are going to use for probability when using binomial distribution, right? So let's have an example for binomial distribution. Example number one. Right, example number one. If X follows binomial distribution with 7 and 1 over 6, find A, P of X equals to 3, P of X equals to 3, B, P of X is less than or equal to 2, X less than or equal to 2, and C, P of X is greater than 3, P of X is greater than 3. Alright. Solution. We are given a distribution already. Probability X follows binomial distribution with 7 and 1 over 6. This means that we have N 7 and P 1 over 6. Therefore, Q is 1 minus 1 over 6, which is 5 over 6. This is the information that we have. So, if we are asked to find P of X equals to 3, remember we said P of X equals to X is given by n choose x, p to the power x, q to the power n minus x. So by this formula, if we are asked to find probability of x equals to 3, we are simply substituting 3 for x, which means we have n, our n is 7, choose 3, right? Probability of success, we have 1 over 6, our x becomes 3, then q, we have 5 over 6 to the power n minus x, that's 7 minus 3, which will give us 4. Then we put this in our calculator. If you punch this in your scientific calculator, 7 choose 3 times 1 over 6 to the power 3 times 5 over 6 to the power 4, we get 0.078. 0.078, right? This is for p of x equals to 3. Then part B. Part B, we want to find probability of x is less than or equal to 2. Probability of x is less than or equal to 2 is the same as probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. X is less than or equal to 2 is the same as x equals to 0 plus x equals to 1 plus x equals to 2. So substituting these ones in our formula, we get for p of x equals to 0, we use n choose 0, which is 7 choose 0 times 1 over 6 to the power 0 times 5 over 6 to the power 7 minus 0, that's 7, plus p of x equals to 1, we use 7 choose 1 times 1 over 6 to the power 1, 5 over 6 to the power 7 minus 1, that's 6, plus 7 choose 2 times 1 over 6 to the power 2, 5 over 6 to the power 7 minus 2, that's 5. Now you can put this one in our calculator, this one, then you add the results. So let's start with 7 choose 0. Or you can punch all of them once. So if we punch 7 choose 0, remember this is 1, so we can punch 5 over 6 to the power 7 plus 7 choose 1, 1 over 6 to the power 1, 5 over 6 to the power 6, plus 7 choose 2 times 1 over 6 to the power 2 times 5 over 6 to the power 5 equals to 0.90 to 2 decimal places. Then part C, p of x is greater than 3. Probability of x is greater than 3 is the same as 1 minus x greater than 3. It means you want 4, 5, 6, 7, 8, 9, 10 up to I don't know, but we can simply say it's 1 minus p of x is less than or equal to 3. P of x is less than or equal to 3. So all the probabilities, since they add up to 1, we can subtract those probabilities that we don't want. In this case, we don't want p of x equals to 0, 1, 2 up to 3. We want 4 or more, right? So in this case, we have 1 minus probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2 plus probability of x equals to 3. Remember, p of x 1 plus 2, 0 plus 1 plus 2, you have already got 0.90. So you simply find p of x equals to 3. So that will be 1 minus, if we substitute in our formula, we get, here we simply find 7 choose 3 times 1 over 6 to the power 3, 5 over 6 to the power 4. Then you add to, this is 0.90. If you add all this, I'm sure you will get 0.904. Then your final answer will be 0.096, 0.096. So this is how you find your probabilities using binomial distribution, right? Let's have another example still on binomial distribution. Question. Example number 2. A coin is biased so that the probability, a coin is biased so that the probability of obtaining a head is 2 over 3. Right? Find the probability that if in 5 tosses, find the probability that in 5 tosses of the coin, comma, exactly 2 heads are obtained. Exactly 2 heads are obtained. That was part A. Then part B is saying find the number of tosses required. Find the number of tosses required. Find the number of tosses required for the probability of throwing. For the probability of throwing. For the probability of throwing at least 1 head is greater than at least 1 head. At least 1 head is greater than 0.9. Right, this is a typical Cambridge exam question. Right, we are given that a coin is biased so that the probability of obtaining a head. So in this case, our probability of success of obtaining a head is 2 over 3. We have our P as 2 over 3. Find the probability that in 5 tosses, therefore n equals to 5 and q equals to 1 minus 2 over 3, which is 1 over 3, right? So this is the information that we are given. Now the first question is saying exactly 2 heads obtained. P x equals to 2, x equals to 2. But remember, we have to write the distribution first. X follows binomial distribution with NP. Our N is 5, our P is 2 over 3. That's the distribution, right? So for P of x equals to 2, we have 5 choose 2 times our probability of success 2 over 3 to the power 2, probability of failure 1 over 3 to the power 5 minus 2, we get 3. Then if we punch this in your calculator, if you punch this in your calculator, I'm sure you are now able to use your calculator. Try to punch this in your calculator. Then part B. Part B. Find the number of tosses required for the probability of throwing at least one head is greater than 0.9. At least one head. At least one head, it means P of x is greater than P of x is greater than or equal to 1. Then, and this is the same as 1 minus P of x is less than 1, right? So, in this case, at least one head. At least one head, this can be written as 0.9 is equal to 1 minus P of this one is the same as P of x equals to 0. Remember, x is less than 1 is the same as P of x equals to 0. Therefore, 0.9 is equal to 1 minus P of x equals to 0, which is n choose 0. Our n in this case is 5 choose 0. Oh, sorry. We have n choose 0. We want to find n. Then our probability of success 2 over 3 to the power 0 times 1 over 3 to the power n minus 0. Right? So we can rewrite this. Remember, n choose 0 is 1. 2 over 3 to the power 0 is 1. So that will be 0.9 equals to 1 minus 1 over 3 to the power n. Right? Now we can rewrite this as 1 over 3 to the power n equals to 1 minus 0.9. Then 1 minus 0.9 will get 0.1, which is 1 over 3 to the power n. Then introducing logarithms both sides. We have logarithm here. N ln 1 over 3 is equal to ln 0.1. Then divide by ln 1 over 3 by ln 1 over 3. Therefore, our n is equal to, so since this was greater than 0.9, we are now punching ln 0.1 over ln 1 over 3 in your calculator, and that will give you 2.09. 2.09. This is not, remember we said greater than 0.9 here. We can use the original sign here. Greater than. So whenever you are dividing by ln 1 over 3, ln 1 over 3 is a negative number, your sign will change. So your n is greater than, therefore n is equal to, we consider whole number, the next whole number, which is 3. Right, so this is how we solve the equation in this case. Right, for this one you can punch in your calculator, then you get your answer. Thank you for watching this video. See you in our next lesson.